Hi class, so this is the last section in chapter 5 and thus the last section for the material that'll be on the midterm exam, right? So section 5.4 is titled Finding Empirical Probabilities, right? So remember that empirical probabilities are also called experimental probabilities, right? So it's not theoretical, it's where we're actually carrying out an experiment to find a probability, right? And remember, they can be useful because in some situations, finding the theoretical probability might be really tough, right? So what we can do is we can find empirical probabilities and try to estimate what the theoretical probability might be, right? So in this section, we're going to use simulations to find empirical probabilities. All right, so remember, empirical probabilities are based on observations of real life events, right? So things that are really happening. And these are just a few examples of empirical probabilities, right? So like a baseball player's batting average, right, is an empirical probability. And the percentage of times a bus arrives late is an empirical probability, right? So we're actually getting this from real life events. So empirical probabilities. So as I was saying, when we can't find data or when a situation is too complex for us to find the um, empirical probability of a random event, we can sometimes simulate the situation and generate data needed to find the empirical probability, right? So what this is saying is sometimes we can use simulations to get the data to find the empirical probability, right? So we could actually go out and you know, for example, if I wanted to find, um, what's the probability of a Toyota driving around Marion, Ohio, right? So I could go out and record, you know, how many Toyotas are driving around Marion, right? But that might be really hard to try to capture, right? So a simulation could be useful, right? So simulations are particularly useful. Like let's say I want to flip a coin 100 times, right? So flipping a coin 100 times can can be a lot of work, right? So I could use a simulation instead, right? So steps for a simulation. So step one, you need to identify the random action and the probability of a successful outcome, right? So in step two, you need to determine how you're going to simulate this random action. So for example, maybe you want to use technology. So for example, we looked at a coin toss simulator I gave you a website for earlier on, and we're going to look at that again today actually. But that's one thing you could use. Or we also looked at an example of using a random number table. Um, I think in the same section, the same video that we looked at the coin toss simulator, right? So you could use one of those, for example. And there is a random number table in the back of our text, right? So then you need to determine the event you're interested in, right? So what are we interested in? Are we trying to find the probability of getting tails or heads, right? For example, if we're doing a coin toss. And then also we want to know, how am I going to simulate one trial, right? So what am I going to define as one trial? And then I need to carry out a trial and record whether or not the event of interest occurred, right? So if we're trying to find the probability of getting tails, did how many tails occurred, right? So then we need to read this trial many times, and it's recommended to do this at least 100, and then count the number of times that event occurred, and then you're going to use that data to find the empirical probability, right? So we're going to look at a law associated with probability in a moment, and it's called the law of large numbers, right? And and that's a big driving force. We need to have at least 100 data points, right? We need many times. It'd be much better to have more than that, but you don't want anything smaller than 100. Right? So here's an example, right, of walking through. So let's say I want to find, well, what's the probability of getting 3 heads if I toss a coin 3 times? So step one, as we talked about, we need to identify the random action and the probability of a successful outcome, right? So the random action is, in this case, um, the outcome of a single coin toss, right? So the probability of getting a head is 0.5, right? So if we want to determine how to simulate this random action, here maybe you want to use a random number table, right? Where we let even digits be tails, so 2, 4, 6, 8, and 0, right? And odd digits be heads, so 1, 2, 3, or excuse me, 1, 3, 5, 7, 9, right? So even would be 0, 2, 4, 6, 8, and odd would be 1, 3, 5, 7, 9, right? So then 3, determine the event you're interested in. Well, we're interested in if we can get 3 heads and 3 tosses, right? So it says explain how you would simulate one trial. So we're going to read off 3 digits from a table, and each digit represents a toss, right? So record T for even numbers and H for odd numbers, right? Is how we could do that. So 5, it says carry out a trial, record whether or not the event of interest occurred. So if 3 heads occur and 3 tosses, we say yes. If not, then we say no. And then you'd want to repeat the trial many times, right? At least 100, and then count the number of times your event occurred. So then the empirical probability would be the number of yeses divided by the total number of trials, right? So here's, continue to go with the example. So if we use this random number table, we look at line 1, right? What we said we were doing is let's look at just the first 3 numbers. So I have 2, whoops, didn't mean to jump over. So we have 2, 1, 0, right? These 3 numbers here. So I wrote them down here. So that correlates to, right? Remember, even was tails, so this would be tail, head, tail, right? And that makes it no, right? We did not get 3 heads in a row, so we write no. And then the next numbers are 3, 3, 3. So that would be head, 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 which is yes. So we did get 3 heads in this case. And then next we have 2, 5, 2, right? So that's tail, head, tail, and that's a no. Right? So you do this at least 100 times and count how many yeses you have, right? And then divide by how many trials you did. And each one of these is a trial, right? So 2, 1, 0 is a trial, 3, 3, 3 is a trial, 2, 5, 2 is a trial, and so forth. Right? So then here is the law of large numbers, right? So what you want to remember is that, you know, one way to find the theoretical probability is if you did the empirical probability and repeated it an infinite number of times, right? And we can't actually repeat something an infinite number, but imagine if you could, this will be exactly equal to the theoretical probability, right? So if we could continually keep trying this event, eventually it's going to reach the theoretical probability. So the law of large numbers basically states that the more times that you repeat a trial, that empirical probability is going to get closer and closer to the theoretical probability, right? That's exactly what this is saying, right? So that's why we want to do at least 100 trials, as stated before, because we want to have a large number, right? We repeat this a large number of times if we want to use this number to estimate what the theoretical probability might be. So I just wanted to go into Canvas, and under section 5.1 is where I put a link for the coin toss simulation. So if we go to this, right, now I'm going to type in, let's say we want to flip it 10 times, right? I'm going to click toss them. And I'm actually going to ask to display this as a table format, right? So here we have 5 out of 5, which is 50% heads, 50% tails, right? And that's what we would expect. That's the theoretical probability, right? So, which is perfectly fine, right? Nothing wrong with that. But to prove my point, I'm going to clear results, and I want to do this 10 more times. So I want to get something that's not theoretical, right? So, you know, if you do it one time, you could certainly get theoretical probability, but I want to try to get an instance where it's not theoretical, so then I can show you something, right? So let me toss one more time. Right? So now I have 6 out of 4, right? So we want to do this, repeat this at least 100 times, right? So I'm going to go up here and tell it to do 10 more times, right? And I'll just hit toss them. Right, so now we're at 20. So the probability of getting a heads is 10 out of 20 is the theoretical probability, right, that we would expect. If I click toss them again, we get probability of heads is 14 out of 30, right? So I click toss them again. So we'd expect 15 out of 30, right? Theoretically. So if we click toss them again, we get 19 out of 40, right? Toss them again, 22 out of 50, right? We would expect 25 out of 50 here. If I keep doing this, eventually it's going to get very, very close to a half, right? So you can see how the numbers keep flirting, right? Being very close to half. So let me go in, let me type in 1,000 now, right? Speed this up a little bit. So I'll click toss them. So you can see now how close it's getting. Right? So we did this 6,100 times, is exactly half. Right? So again, the idea here is that if I repeat this an infinite number of times, it'll get closer and closer to the theoretical probability. Right? Alright, so make sure you know law of large numbers, right? That's an important concept. It's also in the text if you prefer to read that rather than hearing me talk about it. That might help. If you have any questions, please send me an email.